Hi, I'm Professor Baldwin, and today I'm going to teach you about the hyperbola. The hyperbola is the last conic section we're going to talk about in this class. Now, remember that all of our conic sections start with the exact same general equation, but the rule associated with them is what tells us the type of conic section we will have. A hyperbola is when A or C is negative. So the coefficient on the x squared or the y squared term is negative, not both. A and C have to be opposite signs to give you a hyperbola. If they're the exact same sign, you have an ellipse. Now let's look at the two different graphs here. On the left, you have the vertical orientation of a hyperbola. Notice that it opens up and down. On the right, you have the horizontal orientation. This opens left and right. The similarity between these two graphs are the dotted lines, the asymptotes. The asymptotes are very important in graphing hyperbolas. And in order to graph the asymptotes, you need to be able to find the center, HK. Notice that the center is equidistant between the vertices on those hyperbola graphs. Now let's compare vertical orientation and horizontal orientation. With vertical orientation, the standard form A is less than 0 and B is greater than 0. You can see that here. The negative sign is on the x term, where standard form for horizontal orientation, A is greater than 0 and B is less than 0. That negative sign is on the y terms. Now, the vertices for each type. With your vertical orientation, you keep your x coordinate from your center, and it's the y coordinate that's being altered by that b value, right? That's the distance from the center. And with horizontal orientation, we keep the y coordinate from our center, and the x value is what's changing. So let's go back and look at those graphs to get a better understanding. So the vertices are equal distance from the center. And if you look at our vertical orientation, our vertices here are on this same vertical line. They're on the line x equals h, which is why the x coordinate for both vertices is exactly the same as the x coordinate for the center. Now, if you look at your horizontal orientation, those vertices all fall on this horizontal line. That horizontal line is y equals k, which is why the vertices for your horizontal orientation have a y coordinate that is identical to the y coordinate of the center point. I want you to also notice these asymptotes, our dotted lines, right? The dotted lines for both of these hyperbolas. Notice that they go through that center point. That center point is crucial to getting your graph correct. Now, how do we find the asymptotes? When you get your hyperbola from general form to standard form, you can easily identify the values of h and k, which get you the center point, and a and b. The slope of your asymptotes is negative b over a and b over a. So the values of those denominators that are being squared. Let's look at an example. Here we're given the equation And we're given this equation already in standard form or close to standard form, right? We need to make a couple changes to easily identify H, K, A, and B. And we need to identify the orientation, the center, the vertices, and the asymptotes. And then we're going to use all of that to graph the hyperbola. First, we want to rewrite this equation in more perfect standard form. So the first numerator is good. It's x minus that constant squared. But the denominator should be something squared. Well, 1 squared gives us 1. Our second numerator, that should be y minus a constant term. So it needs to be minus a negative 1, and then squared. The denominator is 9. We need it to be something squared, and we know that 3 squared is 9. And then we want it equal to 1. Okay, this is the format we want. Now let's identify the orientation. The orientation is determined based on where that negative sign is. Our negative sign is on the x variable. Because it's on the x variable, we're going to have a vertical, my pen's not working, a vertical orientation. So it's going to be a hyperbola that looks like this. Now let's identify all of those values we need. We know that h is equal to 3, k is equal to negative 1, a is equal to 1, and b is equal to 3. We need to identify the center, and we know that our center is the point HK. My pen doesn't want to write a K right now. So that is the point 3, negative 1. So let's plot that real quick. There's our center, 3, negative 1. Now we know because our center is 3, negative 1, and our orientation is vertical, we know that our vertices are going to be on that line of x equals 3. So we know that we're going to keep our x coordinate, and we just need to find the y coordinate. Our y coordinate is equal to the value of k plus or minus the value of b. So here that's negative 1 plus or minus 3. So we have negative 1 plus 3, which is equal to 2. And we have negative 1 minus 3, which is equal to negative 4. So let's plot those two vertices. We have 3, 2, and 3, negative 4. And notice that these vertices are equal distance from that center point. Okay, we have our center and we have our vertices. Next are to do the asymptotes. Our asymptotes are going to be the slope negative b over a and the slope b over a. So the first is going to be negative 3 over 1, or a slope of negative 3. And the second will be a slope 3 over 1, or a slope of 3. Remember that the asymptotes go through the center. So you're going to start at the center and use your slope to count and plot more points to help you draw the asymptote. So let's do the first slope of negative 3. That tells us from our center to go down 3 and right 1. Or you can go up 3 and left 1. So we have this general line for that first asymptote. Now we can do the asymptote with a slope of 3. Again, start at the center. You go up 3 and right 1. And you can do that as many times as you need to get a straight line. You can also go down 3 and left 1. And there's our other asymptote. Now that we have our asymptotes and we know where our vertices are, we can draw our hyperbola. Remember, it's going to approach those asymptotes on each side. So now you can see how important those asymptotes really are when you're going to graph your hyperbola. They help you find those end points. Thank you so much for watching. I hope you found this video helpful, and I hope you'll check out some more of my math tutorials.